Hello, good morning, classical physics. I wanted to ask you about how to get electrons from this plate. Can you help me?
Yes, of course. If you want to emit an electron from this plate, you must consider the intensity and the wavelength of the light. The intensity of the light is depend on the energy of the light. So in this expectation graph, you want the intensity to increase, so wavelength will decrease. The intensity of the light depends on the energy. So you want to have a waiting time with the electron to emit from this plate. And if you want to increase the current will increase with the intensity. So you must increase the photons which are produced from the light.
Okay, thank you. I'll try this and come to you again.
The next day.
Hello, good morning, classical physics.
Hello.
Yesterday I tested your hypothesis experimentally, but the results will match your graph. Can you explain this to me?
Of course, you had a mistake.
No, I didn't.
Yes, you're right. Embarrassing moments.
You wait enough period of time?
No.
Of course you.
Just then.
Hey, I have an explanation for that. Can you hear me? Of course. In order to have an electrons emitted from a photons from your expected hypothesis you said, you need to have an energy of light more than the work function of the material. How? Okay, work function is defined as the minimum energy of a photon to allow the most energetic electron to move, and it depends on the type of the material. When the energy of the photon is more than this work function, the electron moves from its energy level. No, it's wrong. No, you can see my explanation. The intensity of light depends on the number of photons, and because light has a duality too, so it works.
Duality?
Yeah, it works as a
Light is a wave.
No, you are right. The light acts as a wave, but sometimes it acts as a particle too, because it has a duality. Don't you trust here? It's a no.
I think that's right.
No. When you increase the intensity of light, the number of photons increase. So this time, the number of ejected electrons will be more.
Light is a wave.
No, and you have a law of photoelectric effect that states that the kinetic energy is equal to the energy minus the work function. All of these are right to this experiment.
Okay, let's try this experimentally. What about it?
Okay, let's try.
What follows is a brief construction.